Okay, let's start with a question like this. We're going to talk about logarithms and exponents today. This one hopefully will not be too difficult to be able to do this. Sorry, I shouldn't do the negative. You guys will definitely be able to do this. How do we solve something with different bases? There's two ways to do it. Let me give you the first way.
Oh, you guys. Yeah, that's
Sorry?
right.
Go ahead, Kelly. Yeah, that's the first step to always try and do it. If you can make them the same, it's called a change of base. If you can make them the same base, do it. So 4 is the same as 2 to the power what? 2. 2 to the power 2. Okay. I'm going to talk to you at some point today. Bad. Remember that test I talked to you about yesterday? I couldn't find it. So I don't think you did it because everyone else is in the class. So we got to talk what we're going to do about that. No, the other one. We'll try it. What's that? Do it. Oh, we got to talk. Okay, I'm going to hit pause here for a sec. No, I'm not going to hit pause. I am going to hit pause because I shouldn't say this. Oh, no. Let me do this mechanical software. Okay, let's use our power rules here. Can somebody be brave? Can somebody else be brave? Let's use Spider-Man today. So Emma, unfortunately, you're next. 2 to the 2 to the x minus 9. What does that change into? I couldn't hear you, so I'm going to assume you said 2 to the 2x minus 18. Okay, so things are looking good here. Okay, guys, I can hear. Please. For everybody that came in on your test, I'll give them to you after. Okay. So, can I please do this? Thank you. Okay, so remember the power rule for that. Just if you're multiplying a bracket, raising something to a power, it's like multiplying. Okay, Alistair, what do you do at this point in the game? Drop the base. You were in my grade 11 class. Yeah. I tried you.
Would it rather voltage at the co-op office, please? Rather voltage in the co-op office?
Well, I think it's good. Okay, so using our, so just what happens is here, when the bases are the same, that means the exponents are the same. So you can just do the algebra with the exponents, okay? So I'm just going to solve that, and that means 21 equals x. And that's the end of the question. Okay. Is this coming back to most of you, like hopefully from grade 11? That type of question? Luke, go ahead.
Divide by 3.
No, because what, right, x comes over to as a negative, right? So 2x minus.
Okay.
So right, I'll show my work. Yeah, I'll show my work. I'll show my work.
I had the signs on. I use it to
Okay, so there's that.
Oh, yeah.
Okay, logarithms were the main reason we use logarithms in grade 11 were to solve things when the bases were different. Okay, so I'm going to do an example like that, then we'll get into all of my laws of logarithms here. So example 2 says 5x plus 9, 5 to the x plus 9 equals 4. Okay, the difficulty with this one is what? Why is this one more difficult than the last example? Yes.
Because you can't make the bases equal.
It's very, very difficult to make the bases equal. Okay. So what you're going to do is you're just going to take the log of both sides. Now there is a button on your calculator called log. If I do not write anything with it, what is the subscript to the log? If I just write log.
Be a base 10.
Base 10, this is, okay? And I will not write that unless it's something different, but that's assumed to be base 10. What's the purpose of me doing that? And we'll talk about our logarithms in a little bit here. What does that do? It doesn't matter if it's or so for this here, what is the, when we do a log, what's the purpose of that one, really? Okay. Sort of. That's probably right. Now, let me rephrase. That's probably correct. Okay, but I don't really understand. So ask somebody else here. Go ahead.
When you switch to base 10 or base 5 to power
Yeah, you guys are thinking way too complicated on this. Go ahead. Yes. One of our rules is going to be this changes it to x plus 9 log base Did I want to make that? Why don't you stop speaking? Good, you sound like you're on speakerphone. Yeah, you're wonderful. That's great. How can I help you this fine morning? Yes, he is. Okay. No, it's no problem. Okay. Tell him the tune. Do a phone call. He says it'll only take 10 seconds. I might believe him. All right, so back to here. The nice thing with this is now, hold on guys, please. The nice thing with this, I can calculate this on my calculator. What do I do to solve for x? What's the next step, please? Solve for x. Yeah, go ahead.
Send log 5 to it.
Yeah, so I'm going to say x plus 9 equals log 4 over log 5. So the nice thing is your calculator can solve that for me.
Oh yeah.
And I got 0.86. Is that close to what people got? 86 I got. So x equals negative 8.14. Is this coming back to people a little bit from grade 11 and 12? Okay. All right, here we go. Example 3. Okay, this question reeks of awesomeness. If you don't mind me saying. Takes it does. All right. Now, if you don't know what to do in a question like this, because this is starting to look a little complicated here, okay? I have that darn old 1 in there. That's the thing that I'm not really liking. We'll deal with the 1 in a sec. James, do you have any ideas on what we can do? Okay, go fast, go fast. But I need you to be here. James, do you have any idea what to do there? Any guesses? Your guesses are okay.
I'm not sure.
Okay. Kelly, on track? You can do that. You can do that if you want to. I might do something first, though. Exponential form, meaning you write it as 1 plus root x equals 10 plus 1 minus root x. Is that what you're saying, exponential form? Okay. Okay. So what I might suggest, I might do something like this instead. I might change it to log of 1 plus root x minus log of 1 minus root x equals 1. I might do that. Okay. Can anyone recall what the log rules are for subtraction? What does a subtraction for log turn into? Yeah, quotient or fraction. Very good. So this is log 1 plus root x. We're going to get to the laws in a second. I just want to see what you guys remember. Chris, you're not coming back to view at all?
No.
Chris, did you skip this week?
Chris.
I didn't mean to pick that.
He's
Sorry.
like my spot.
I didn't. You think that's... Okay,
That's why
you're
I'm
raising
here.
your hand and everything today.
I know, that's why I'm
This is good. This is good.
Yeah, I'm excited.
Okay, so let's deal with, this is looking good, but not yet great. Okay, so I have log of something equals 1. I want to get the right-hand side to be log of something so that I can just cancel the logs and then be done with the question, right? That's what I want to do. So what does 1 equal? Log of what equals 1? Log of 10, right? Yeah. So it's going to be log Now, Bailey, other than as a guess, why would that be 10? Like, why would it not be 6 or E or something like that?
Because it already has a log in it.
Luke, go ahead.
It's always
Why though? Why? It is, but why? Mike, go ahead.
because it's for the base.
Right, this is base 10. And one of the rules we're going to talk about, like if it was log 2, like log 2 to the 2 would be 1. Because really what happens is, that's where the 1 goes. The 1 goes as the exponent there. Okay, and log 10 to the 10 cancels out to be 1. Okay, great. So this is looking okay. Somebody will tell me what to do next. So say I think you're up. What do we do at this point, if anything? Cancel the logs. So it's going to be 1 plus root x all over 1 minus root x equals 10. Now this is something we can actually solve. Or a little bit more easier we can solve. Okay. Now there's no logs, so this is back to grade, I don't know, maybe 10 question or 11 question at this point. Can you be brave, please? If I want to solve for x, what's the first thing I should do? Okay. Somebody help her. Brennan, go ahead. Yeah, totally. Okay, so we're going to multiply this, going to change to 1 plus root x equals 10 bracket 1 minus root x. Nathan, it's your time to shine. Any suggestion on what we can do now? Totally. Okay. Or I guess you guys don't say totally, literally. And that's what we do. That's what I was supposed to be doing. You guys only get me on good moods like 1 day a week, okay? So just, you know.
Because of us?
No, not because of you guys. No, why do you guys think you're a bad class? You guys are wonderful. No one's stormed out yet, you know, it's all good. All right. Yeah, let's not talk. We already went there. We're not going back there.
Yeah, isolate the X now.
Yeah, isolate the x. So I'm going to call this then root x. Okay, so I just isolated. Matt told me to isolate, so I did 3 steps for him. I'm assuming that's what he meant. And to finish this up here, Victoria, this is my very last step. Square everything. So x is equal to 81 over 121. Okay, I'm going to give you guys one to try yourself here, and then we'll talk about laws of logarithms. And then we'll keep going here. Now, I know this is somewhat new to people. You guys have all seen this unless you took it last year, you know, in about January. This is probably the last unit you guys did, I would think, last semester. So hopefully it's somewhat fresh in your brains. I saw Luke raise his hand 5 times, so whoever your tutor was last year, he must have been awesome. That was good. Let's do another example here. Oops, I'm going to write example 4 we're on, right? Okay. Okay, I'm going to hit pause in the video. I want you guys to try this one, please. Austin, I want you to stop calculating on your calculator there and to start doing this question, please. Okay, so try it out. This one's a little bit trickier again. You guys can do it. Have confidence in yourselves. You guys are a wonderful class.